Here's an explanation of the Derating calculations related to electrical wiring, specifically addressing the effects of ambient temperature and the number of current carrying conductors in a conduit, referencing the National Electrical Code, or NEC. Let's consider a scenario where 12 120-volt, 20-amp branch circuits are being installed to feed individual duplex receptacles intended for charging utility vehicles. The assumption is that these are linear loads. The design involves running these circuits as multi-wire branch circuits from a 120/208 three-phase panel. First, let's examine the situation where the conduit is run along a roof conduit rack in direct sunlight. We're given a typical summer day temperature of 98 degrees Fahrenheit. The fine print note in section 310.10 suggests an ambient temperature of 128 degrees Fahrenheit for such installations. To determine the required wire size, we need to apply derating factors based on both temperature and the number of current carrying conductors. For a 20-amp circuit, we begin with the base amperage. The temperature correction factor for 128 degrees Fahrenheit needs to be found from the NEC ampacity correction factor tables. Let's assume this factor is 0.76. Next, we must account for the number of current carrying conductors. With 12 circuits and assuming 4 multi-wire circuits each with 3 current carrying conductors and a neutral, we effectively have 12 current carrying conductors in close proximity. The NEC requires derating when there are more than 3 current carrying conductors in a raceway or cable. According to the NEC tables, for 10 to 20 conductors, a derating factor of 50% applies. The calculation then becomes the 20-amp rating of the branch circuit divided by 0.76, the temperature correction factor, and then divided by 0.5, the derating factor for the number of conductors. The result is 52.63 amps. This calculated amperage necessitates a wire size capable of handling at least 52.63 amps after derating. Consulting the NEC ampacity tables, we see that number 8 copper wire, with an ampacity of 40 amps at 60 degrees Celsius, might not be sufficient after derating. If number 6 wire is rated for 55 amps at 60 degrees Celsius, then that conductor would be required. Now let's consider an alternative scenario where the conduit is run inside the building along a wall, resulting in a lower ambient temperature. Assume an ambient temperature of 86 degrees Fahrenheit. In this case, the temperature correction factor is 1.0, meaning no derating is necessary for temperature. However, we still need to account for the number of current carrying conductors. If the circuits are run in 2 separate conduits, each containing 6 current carrying conductors, a derating factor of 80% applies according to NEC tables. The calculation becomes the 20-amp rating of the branch circuit divided by 1.0 for the temperature factor, and then divided by 0.8 for the 6 current carrying conductors. This yields 25 amps. Based on this calculation, a number 14 wire, which is typically rated for 20 amps at 60 degrees Celsius, might seem sufficient. However, NEC section 240.4 4D addresses conductor protection. This section typically requires that overcurrent protection devices, such as circuit breakers, do not exceed the ampacity of the conductors they protect. Since the branch circuit is rated for 20 amps, and section 240.4, 4D often stipulates that number 14 wire can only be used for 15 amp circuits unless specific conditions are met. Number 12 wire is likely required. Number 12 wire is rated for 20 amps at 60 degrees Celsius, aligning with the circuit breaker rating. Also consider NEC 210.20. 20 and 300. 4. Addressing the multi-wire branch circuits, these circuits consist of 3-phase conductors and a neutral. When applying the 80% rule for the number of current carrying conductors, the neutral conductor is generally not counted as a current carrying conductor unless it carries predominantly nonlinear loads. In the case of charging utility vehicles, the assumption is that the loads are linear, so the neutral doesn't factor into the conductor count for derating purposes. Therefore, for the multi-wire branch circuits, the circuit only needs to be derated for the 3-phase conductors. Based on the 80% rule, a number 14 wire might appear adequate, but section 240.4 4D of the NEC mandates the use of number 12 wire for 20 amp circuits.